And we are now live, and we're watching our guest in the dark.
Hello, Jeff. How are you doing tonight?
Oh, I'm still doing fine, and you're still in the dark. and literally for our viewers who may be watching now or later, our guest is actually in the dark. Not because he has no power, it's because it's actually the middle of the night there.
Yes, it is. It's about 2 a.m. here in not Moscow, but Belgorod, Russia. And Belgorod's about 450 miles south of Moscow.
You know, fairly close to the Ukrainian border, maybe about 30 or 40 miles.
Probably even a little closer than that, maybe about 20.
Yeah. So, and it's a lot colder there.
Yes, we are at 36 degrees, and we've been hanging out in the 30s all day.
Yeah. I fear we're gonna have we're supposed to get colder next week here, but since there's no snowpack anywhere, none in Iowa, none in Minnesota, none in Nebraska or the Dakotas, so a cold front's gonna come through from the northwest, pretty much an Arctic front, but the air is going to be so modified, it's just going to drop temperatures to seasonal.
Yeah, that's true. That's true. Without a significant snowpack, that'll have a modifying effect on these air masses at this time of year.
The thing that concerns me before we go into...
Uh-oh. Jeff,
keep looking.
Are we losing your connection?
On my end or your end?
Yeah, I heard a little static in there. So go ahead and repeat.
Okay. This is why my camera's not on, because I don't dare know when my internet's going to decide to go take a dump somewhere. But that I worry when I look at the models and have seen that it's not going to rain a whole lot for quite a while. And we've had some red flag warnings, and there's been some wildfires in the plains that it's not as bad as 2012 it was. I think it was 2012, whatever. Yeah, 2012.
Yes.
But it's sure wanting to be like 2012 again if it doesn't start raining again soon.
Yes, and I think that for the summer coming up, I don't think it'll be that bad, especially in the Missouri region. This type of a pattern where we have a very weak El Nino that's been persistent, and it's going to continue, at least the models project it to continue through the summer and the fall. And using statistics for our region, these type of transitions where you have very little transition usually end up being pretty good rain-wise and temperature-wise in the summer.
All right, just a minute. I'm going to try something. Come on. No, that didn't work. Darn. Oh, well. I tried something. That didn't work. But anyway, so we'll go fully into the actual interview. And by the way, for everybody watching, even though where he is right now, it's the Saturday the 14th. We're doing this on Friday the 13th of March. Today is our guest's birthday.
Yes, it is, and my actual time of birth was 5:30 in the afternoon Eastern time. So it just passed that time a short time ago here in Moscow, Belgorod.
Yeah, he doesn't know where he is. He's in Moscow. He's in Belgorod. He could be in Siberia. We don't know, but anyway, so we're not going to mention his age, but he's turned 39 again.
Well, I'll take that.
So, but he's actually older than that, but he's not like ancient. So, but I happen to know when I went through your stuff that you grew up, or you were born or grew up, wherever, in pretty much what I would say the Finger Lakes region of New York. on the northern end. So I would assume, given that you are from that part of New York, that something weather-related got you interested into meteorology or weather in that aspect.
Oh yes, the Finger Lakes are well known for being in part of the upstate New York snow belt. But what really got me interested in meteorology was the big tornado outbreak of 1974, the big one that devastated towns in the Midwest and Ohio, and in our part of the world at that time, we just got heavy thunderstorms, and I was fascinated by the news reports and everything else. And the thunderstorms also, I wondered what made them tick.
So, and that was when you were like, I'm going to really age you. You were pretty much in elementary school, so.
Yeah, I was 8 years old at the time, and it was quite an experience, and that really turned me on to weather.
So then when you did go to school, you went to community college first, pretty much as I would call it, to get rid of the stuff that's not meteorology.
Oh yes, yes. I had some advice from a weathercaster in the Syracuse area. I had written to him, and he was very open about advising me on how to get educated. And he said a community college would be a great way to start, and then go to SUNY Oswego after that.
And then after you graduated with your bachelor's at SUNY Oswego, you went to Purdue and got your master's and your doctorate there.
Yes, I got my doctorate in atmospheric science and also my master's. And when I arrived at Purdue, I was very interested in severe weather, tornadoes, thunderstorms, and the like. But when I met my advisor, he let me know that we would be working on something more synoptically oriented. And I just went upscale from there in my love of weather.
And that's pretty much when you went from the mesoscale to the synoptic scale to like climate and all that stuff. So that's when your focus kind of was shifted at that point.
Yes, it changed dramatically especially during my early PhD years. I decided to tackle the issue of atmospheric blocking, which is something that you don't hear a lot about unless you watch the Weather Channel or something like that. But blocking is just a persistent ridge in the jet stream that more frequently occurs over the oceans and over Eastern Europe, Western Russia.
Similar to, let's say, like the Bermuda High.
A little bit like the Bermuda High, and but more interacting with the storm tracks.
Yeah, so it wouldn't be like, say, like a omega type block.
Yeah, these are the very things that we're looking at.
Okay, I wanted to be sure, because omega blocks, I see those all the time on models, and it's like, well, it's an omega block. And the thing is, when you get those, and I've noticed, they don't seem to move very quickly. They just sit and sit, and it takes, and then even if it gets undercut, it's still there, sitting, and it drives, and it would drive forecasters. I would think it would drive them nuts if you have something like this. And for example, I think something similar. It wasn't an omega, I don't think, in 2012 or even in 1988 when we had drought years in the Midwest. That it's just so persistent that you get bland weather or in drought weather in some cases.
That's entirely correct. These stationary systems will cause droughts in the areas they impact. Good examples of this also are the Alaska 2004 event in the summertime, Europe's summer of 2003, Russia's summer 2010. These are all examples of persistent blocking, and they are very difficult to forecast, both their onset and decay.
And so when you've looked at them, are any of them say, stronger than others? And is there, in any cases, are they stronger over some other parts of the world than in other parts? For example, say, like, are they stronger in, say, like the Pacific or the Atlantic, or say, like in Asia, Europe, or the United States, or even in the Southern Hemisphere, let's say Australia or Africa or South America?
Yes, blocking tends to be the strongest in the Atlantic area, followed closely by the Pacific, and then your areas over Asia, Eastern Europe tend to be very much weaker events, and they also tend to be stronger in the winter season when your equator to pole temperature gradient is much stronger. In the summertime, they tend to be very weak.
So this would be similar to, say, like a Siberian high stuck over eastern Russia, and it's like 60 below zero.
Yeah, these stationary systems, whether they're blocks or Siberian highs or Bermuda highs or things like that, very difficult to get a handle on.
So then when you have to do climate type issues, and we're going to get to further into that, for example, if you'd say, okay, for example, we're going to use this year, even though you're in Russia, for the Midwest, and you kind of harped on it earlier, of you've seen the pattern we've had, even though you've been in Russia, where we've had this persistent ridge in the west, trough in the east, and then every time, which right now it seems to be more zonal somewhat, and we have this cutoff low to our south that's kind of slowly moving away. And then what I would say is,
Yes, the thing that's causing these problems has been a persistent SST anomaly, or sea surface temperature anomaly, in the Gulf of Alaska region. Last winter, January, February 2014, that allowed for strong ridging and eventually blocking, and that left much of the United States cold. This year it was a little bit further to the east, and that means the western United States, Alaska, and western Canada were relatively warm, while the west coast, or the east coast, and even the Midwest was quite cold.
And do you see kind of differences with when we have like really cold winters to really hot summers? Because they're used to, because from what I can remember, the 1930s we had a lot of cold winters back then, but we had the Dust Bowl years.
Oh, yes, yes. We've done some research lately to look at spring to summer transitions. And what we see is that during El Nino years, you have a smaller annual temperature cycle, a warmer winter, cooler summer. La Ninas tend to produce the opposite, cooler winter, warmer summer, at least in our part of the world.
Even though right now we're heading into a weak El Nino, so weak El Ninos, I mean, is it even going to, say, do much of anything for climate based on what a typical El Nino would do in the States, or in hindsight the Midwest?
Yeah, the statistics show that it almost isn't the strength of El Nino that's important as much as it is as to where the warm SSTs that are associated with it show up. If they show up in the eastern Pacific, you tend to get a very split flow zonal pattern over the USA and North America. And that tends to mean cooler weather for the southern tier of states and warmer weather for the northern tier of states. This kind of thing we saw with the El Ninos that occurred in the 80s and 90s. There's another type of El Nino where the SST pattern is more in the central Pacific, and those kind of El Ninos force colder weather over the eastern U.S. And it's just a matter of the fact that it makes a difference in where it sets up the ridge trough pattern.
So, given what we've seen, would you kind of get the idea that the El Nino we're kind of going into, even if it's a weak one, is more centered toward the Central Pacific than the East Pacific?
Oh, yes, yes. Not only did we have that warm SST anomaly in the Gulf of Alaska, but this year the El Nino was very strange. It attempted to set up an anomaly in the Central Pacific, and for a little while it showed one in the Eastern Pacific as well, but that didn't seem to materialize as well.
And for those that would know, I think if I probably mispronounce it, but I think it's a Mendoki El
Uh,
Nino.
yeah, yes, that's it. A Japanese researcher.
Yeah. So with all that, will this pattern that we've been seeing continue, and how long will it continue? Will the El Nino go away? Will it get stronger? Do we really know?
No, that's the worst part about these events is that predicting their transition is very difficult. As long as they remain in the state that they're in, long-range prediction is somewhat easier. But predicting when these things will transition, and then long-range prediction with that, very difficult.
Now, when we go to climate, the big thing is climate change, global warming, which there's a lot of differing opinions about it, but I know for a fact that you're a skeptic about it. However, you have said that it is you acknowledge, according to what this I've read, that humans are somewhat involved, but it's a cycle similar to, let's say, like El Ninos, La Ninas, and then you have the solar cycles, or if I'm thinking that right, where it seems like we have these cycles every 20 or 30 or 40 years where it gets warm, then it gets cold, then we have severe weather outbreaks, we have tons of hurricanes, then we go many years without many.
Oh yeah, climate is just a fascinating area to look at. If you look at some of the recent papers that have come out and said, okay, we can measure a radiative component that we think is due to CO2, and if you work the numbers by plugging it into a model, you can account for all of the warming of the 20th century through human-induced CO2. At the same time, if you look at climate history of the last 2,000, 4,000 years, you see ups and downs that are very much in line with what we're seeing today. And so the answer is somewhere in between. It's hard to put a percentage, so to say, on the contribution between humans and nature. But if you were to say it's 50% that humans are causing 50%, nature's causing 50%, that would be one way to look at it.
Well, and I've also thought this, and I think a lot of people have too, there's a lot more humans living on Earth now than there's ever been. So
Oh, yeah.
even if humans are causing it, of course they probably would. There's a lot more CO2 coming out.
Yeah, there's a lot of CO2 that comes out of our activities, manufacturing, fossil fuel use through your automobiles, things like that. And with more of us, we're producing more. But even at that, our contribution to the entire cycle is fairly small. What folks think is happening is that we're upsetting the cycle a little bit with our contribution, and that contribution is small but important, and that it's accumulating. So it's a very fascinating issue.
And the thing that I wonder, because they always say, well, the globe has been warmer whatever month it was. They always say this. And it seems to always be a time when the states, which seems to be like the mecca of climate in hindsight, is always cold. For
Yeah.
example, last winter, which was horribly cold in North America, and they said it was like the warmest. And it seems like, well, it's not warm here, so where is it warm?
Yeah, that's right. People tend to get a local bias toward looking at climate. For example, during the 2012 Olympics that were in Britain, it was unmercifully hot here in the summertime, but in Britain and many parts of the other parts of the northern hemisphere, temperatures were below normal. Now we're seeing North America seeing below normal temperatures, and a lot of places seeing above normal temperatures. And so these kind of things are going to happen locally, but the thought is that the globe is warming as a whole, and steadily so.
So, is there any connections between, say, when we were hot but Europe is cold? Is there any connections when it seems like the opposite of whatever's occurring here in the States seems to be occurring in Europe?
Yeah, depending on how the jet stream is configured, where your trough ridge patterns lie, I notice that a lot of times the weather in Colombia will be in sync with the weather here. And sometimes it's opposite, but more or less, if it's warm in Colombia, it tends to be warm here. If it's cold in Colombia, it tends to be cold here.
So then there's other type of blocks, because you do mainly high pressures, from what I understand,
Yeah,
anticyclones. So then we have like the blocking low pressures, like Greenland blocks, which I think is a high pressure. I think is
yeah.
it?
Greenland is a high pressure.
Yeah.
There are some that consider closed lows and cutoff lows to be blocking events as well.
Yeah, but the Greenland block is more apparent in the winter than in the summer.
Oh yes, without a doubt.
Yeah, because we've had a lot of those this year, but we had way more last year.
Oh yeah, yeah, and that's been a big part of it too. Not only has it been in the Pacific, but it's been in the Atlantic, which kind of leaves us in a sandwich.
And then so then we have, and I know that this occurred I think yesterday or earlier today when you had the cyclone Pam that hit Vanuatu in the South Pacific, swirling away, and I think there was another cyclone right next to it, which was I think Nathan or something or other, and everybody's all going nuts because this was a Category 5. I don't know. They have categories there, I guess. I don't know, but so when you have these strung type system cyclones, or even if we had a Category 5, let's say like Katrina or something, it just goes where it wants. I would assume it doesn't, unless there's a high pressure that's like one of these blocking things. A hurricane is just going to move it out of the way.
Yeah, that's a good segue to look at blocking and hurricanes and some of these extreme events. There was a blocking event over Greenland and the central Atlantic at the time that Sandy was making its way up the coast.
Yeah.
Typically, you don't see this kind of thing happening because storms that impact the Atlantic coast tend to happen August, September. Here you were late October, strong blocking event as we were going into winter, and it just kind of pushed the hurricane off to the side, bringing disaster to New York. Something like Pam down in the southern hemisphere is just so strong, and it's their typical hurricane season now, that when they get this strong, they can, in a sense, create their own steering currents or just be carried along in the current like a big block, uh, like a big piece of wood in a stream.
So it would be like, for example, with Cyclone Pam or any big hurricanes, and not, I would say big as in size. It would, if you have one of these small type storms that's only a couple 100 miles wide, it's not going to be the same as something that's 1,000 or something bigger wide, where it's going to have more room and it's going to knock things out of the way. Kind of like a bowling ball to bowling pins, it's going to knock everything out of the way.
Yes, yes, and something like PAM that's smaller, more compact, stronger winds. You've got a certain amount of energy in that storm that's that's confined in a smaller area, so you can generate these winds. And imagine a larger storm with the same amount of energy over a larger area. You're going to have weaker winds overall, but the same amount of energy.
So before we go a little further, we'll talk about where you are, not where you are right now, but that you ended up going to the University of Missouri, and you're a department chair there and a professor there. Well, you were, but you're not there now, but you still are. I'd assume when you get back, you still have a job there.
Oh, yes. Yes, what I'm doing now is I'm on a Fulbright scholarship, and what happens is the university will reduce my salary by half, and Fulbright covers the other half, so I still have a job at the University of Missouri. And I served there as department chair for 6 years, and then I stepped down to do this. And I stepped down, and my colleague Patrick Market took over, and he has the job now.
So when you're on your Fulbright scholarship, so we'd ask a very good question because you're in Belgorod, Russia. So a lot of people are probably thinking, why are you in Belgorod, Russia, on the Fulbright scholarship?
I've had a good working relationship with scientists from Russia for about 20 years. I first met a fellow by the name of Igor Mokhov, who I publish a lot with in blocking. I met him in 1993, and then in 2009, a Russian scholar came to the university, or Iowa State University, and paid a visit to the University of Missouri. His name was Yuri Chendev, and he is the department chair here for the Department of Natural Resources and Mining. And I started talking to him, and we discovered we had some common interests, and we decided that if I applied for a Fulbright, that I'd come here for a year.
So what are you doing right now with, well, you're at Belgorod? Are you doing pretty much the same type of research, but it's more centered to, say, Eastern Europe and into Russia?
Oh, precisely. You nailed it correctly. A lot of the things that we've developed for looking at variations in Missouri's climate and trends, and even trying to do some long-range forecasting, we've just taken that and brought it over here.
And so is there any real differences? Because there's not a big, huge Gulf of Mexico to your south. There is a sea down there, but it's not as big and it's not as tropical as the Gulf of Mexico. So is there kind of differences, or is there really not much difference?
Oh, we're finding some differences in how the weather varies here. Obviously, it's colder and it's a little drier, but we're finding some differences as to how El Nino affects this region. For example, Iowa, Missouri tends to get little less snow during an El Nino winter. Over here, they tend to get more. And that just is, again, how the jet stream is impacted.
Yeah.
And we're seeing that the droughts that they get here are a little different than the droughts we get in the USA.
And so how would the droughts be different?
Oh, that's a good question. In the USA, our droughts tend to be a long time in the making. Let's use the example of 2012. If you go back to 2011, about half the months were well below normal in precipitation leading up to this. And it was, the relative humidity was down,
Yeah.
the winds were up, aiding in evaporation. And then the dry spring really set the stage. The drought of 2010 that affected this region, a little different, a lot of blocking, and this blocking started in the spring and dried out the area quite quickly in the summer. The previous 12 months were above average in precipitation. So here the droughts are more jet stream dynamically driven. In the USA, they tend to be more surface driven.
And so, because in the United States, is it for the fact that we have two oceans on either side and a gulf, whereas where you are now, there's a sea well to your south where you are, and there's just land on either side? Is that kind of
Oh,
the differences there?
yes, yes, to a large extent, that's it. And we're a little further south and in the USA. So the jet stream will be well to our north by summertime, so it's definitely not a factor, whereas the subtropical highs will be more the factor for us. In this area, the jet stream can still be in the region during the summer, and with blocking, you'll have a split flow and leaving high pressure over this region and wetter conditions to the south and north.
Yeah, that seems to be what's happening right now here, because we have the jet stream to the north and this one to the south, and this cutoff low that I mentioned earlier is just moving. It's moving almost. It acts almost like it's like a subtropical system, because it went straight north, or it's going straight north, and then it's just going to zip to the east because of a blocking type feature. I don't think it's what I would call a blocking feature, and it's just going to zip it off to the east, but it's not going to be zipped off to the east by the jet stream. Although I think by the time it gets off almost to the coast, it's going to be picked up. But it.
Yeah, when I was looking at this storm yesterday, that my thought went to that immediately, to look at the tropics and see if there's any tropical role being played in this storm, if it was an unusually early one. I've looked at the climatology. We've had them in. It's been very rare, but they've occurred in January. They've occurred in February, but never in March. And I saw a comparison of this storm to the superstorm of '93, except this one appeared to be a little weaker. But somebody noticed a similarity in the initial pattern.
Even though the superstorm of '93 went east and then northeast, and this one's going north and then east, which makes no sense. And
Yeah,
then I'll sorry to interrupt. Then, from what I gathered with this storm, you have the wedge coming down along the east coast as well that I saw, which is
yeah, yeah. The initial situation may have looked similar, but it's certainly been a lot different as it's evolved.
now I got to think, because now my brain is going to be completely overloaded. But so, when you've been at the University of Missouri before you were in Russia, were you still working on what you're still working on now in Missouri, or were you working on other stuff at the time?
No, I've been working on the same things all along since I've arrived at the University of Missouri, mostly looking at blocking, again, local agriculture in Missouri, Iowa, and Kansas has a vested interest in climate variability, and that was something interesting to look at. Long-range forecasting has kind of come along since the mid-2000s, and we're starting to get better at that. So
Now, there's these climate models that go out, and I know there's a climate model, I think it goes out 240 days. I don't remember. I think it's around then. And I've seen them, and I always go nuts because I always want to look months in advance to see if it's even close to being right. In some cases, it kind of has a good idea, but our climate models, when you see them, they show storm systems and precipitation, and it's going to do this like in August or September. are those really not meant to be when you're going to get precipitation? It's more or less finding out if there's going to be a blocking pattern, kind of starting to get a hint of something developing. Is that what those climate models are really supposed to be used for, not for finding out if it's going to rain in 6 weeks or 6 months?
Oh yeah, the old joke among us weather folks, of course, is that somebody's going to approach you now and say, "My wedding's in October. What's it going to be like on October 17th?" And you just hang your head and try to give your best answer. But you're absolutely right about the climate models. Uh, Modeling can only be done for about 10 to 14 days dynamically. And by that I mean using equations and initial conditions and letting the model do its thing. And that dynamic limit is imposed by the makeup of our atmosphere as well as the size and rotation rate of our planet. Past 14, 15 days, the way that you would use climate models is to look at the aggregate statistics. So yes, you wouldn't use that to say, October 17th is going to be a lovely day. No, you would use the aggregate statistics that they create.
More or less where the ridges and troughs might be located, roughly.
Yes, sir. Yes, sir. Where you might have persistent features.
Because I did notice, because this was several months ago, it was back I think in October, and it was back then, and I was looking at it for the winter somewhat. I was like, yeah, they can't even get the forecast for tomorrow right, and I was looking at it, and I kept seeing a persistent cold spells during the winter, but it was like all winter, and I'm thinking, oh great, cold weather. But it only happened in February. December and January were fine. So it kind of got you the hint that it's not going to be a warm winter, but there could be cold snaps. So it gets a good gist of what might happen, but the timing is never going to be quite right.
Oh yes, you provided a nice example for your audience of what we mean by the aggregate statistics.
Yeah.
When we were making our long-range forecast for the winter, we saw some of the same things that you are seeing, and we had said, okay, it's probably going to be a colder winter. Well, November was very cold, and we were
Yes.
pretty encouraged by that. But then December turned out to be pretty warm, and I worried about that because the way we keep track of the statistics is December 1 to February 28. So
Yeah.
November wouldn't count. And then January was close to normal, and February the bottom fell out and kind of saved our forecast.
And I saw that they did right at a couple of days ago, it was maybe a week ago, you had the 121 years of records, and the East had like the top 10 coldest. Many were in the top 5. The West had the warmest, and because you have this pattern where it wasn't walking, you could probably say it might have been, where the East was cold and snowy, the West was hot and dry, and it just stayed that way. And a lot of people would say, well, the winter was horribly cold, and some people would say, yeah, for 2 weeks it was horribly cold, and it drove everything down below normal.
Oh yeah, and that's the problem with statistics and people's recollections and
Yeah.
things like that, and perceptions. Another good example of that kind of phenomenon is 2005 was a very dry summer across most of Missouri, and the crops had a rough time of it. We got 10 inches of rain in 2 weeks, so our summer precipitation looked normal, but June and July were unmercifully dry,
Yeah.
and August was way above normal. And so the record books are going to show that that was a normal summer. Yet June and July were quite terrible. And again, that's the whole thing with these long-range forecast is they provide you an aggregate forecast of the statistics. How that comes out, God only knows.
And so the problem is when the public, and the public can see these climate models, they can see anything pretty much. It's the
Well,
it's the perception that, oh, it's going to be cold. If they're giving like these, if when NOAA's going to give out their like next 3-month outlook, let's say for, we're going to be coming up toward the one for later this month, it'll be the one for April, May, June, the 3-month outlook. And it's going to say it's going to be above normal for temperatures or whatever the heck. So they're going to assume, the public, that it's going to be above normal every day. But that's
yeah.
not true.
Oh yes, that is definitely a perception that if we say, okay, it's going to be above normal by 1 degree or whatever, people will expect that every single day is going to be 1 degree above normal. And it doesn't work that way, as winter 2014 and 15 showed us.
So, and the same would go for precipitation, because I know even on these 8 to 14 day outlooks, they're saying, well, it's going to be below normal in precipitation here where I'm at, and it will also include Missouri, where you would normally be at. And I'm thinking, well, no, duh, because the pattern is not going to, doesn't look like it's going to change. So of course that's simple. But I mean, the longer they seem to go out, because you can look at outlooks. I think NOAA issues outlooks a good year in advance in 3-month cycles sometimes, but I think they do it a year or maybe a slight bit more in advance. So how do they
Oh,
come
yeah.
up with that if they're even going past the normal climate models that in most cases only go out about 8 months?
Yeah, when they make long-range forecasts like this, they're using statistical analysis and also dynamical models. They're using them in tandem, and they're getting better at it. Again, I think long-range forecasting is probably in the same position today as weather forecasting was in the 60s and 70s. You could see the improvement, but in the 60s and 70s, it could still be wrong 24 hours in advance. Now, 24-hour forecasts are almost routine, and I think long-range forecasting is in that boat. We're getting better, but it's still wrong a good chunk of the time.
Now, when we talk about the future, do you see that let's say the climate models may get a bit better? Do you see more emphasis on what you do with blocking and stuff and how it's going to interact? Will there have to be more research done, climate models getting better and whatnot as we move along?
Yeah, I think that climate metals will get better, especially as we do research. I'll tell you where the biggest issues lie in research today is not so much how the atmosphere works. We kind of know the equations and things like that. The things that we don't know are things like ocean to atmosphere transfer, or how does the ocean exchange heat and mass with the atmosphere. The same for land. And the other thing that we are a little inadequate on are clouds. Improvements are going to come slowly and surely, and models will get better, but I don't think we'll ever achieve perfection.
Yeah, because I mean, all you have to do is, and here I think here's one case point and example. You could have you could do the best forecast of long range ever, and then something like Mount Pinatubo blows up, like it did in the early 90s, and the entire climate is changed for the entire globe for a whole year.
Exactly, exactly. There are still some things that I think will just always be beyond our grasp.
So, in hindsight, it's out of the control of even people like you, the model people, because all it takes is one volcano erupting, a big one. I mean, something that just spews out a little stuff, it's not going to do much. But you get something like a Mount Pinatubo to go up, and the climate's different for the whole year. It doesn't matter El Nino, La Nina, blocking, everything's different.
Oh yeah, oh yeah, and those are the things that, like you said, I don't think we'll ever get a good handle on. And that's part of the fun of our job, I think, is the unknown.
So when you're done with your Fulbright at Belgorod, is there any other place you'd want to do research on this phenomenon with the blocking, say in Australia or in Africa somewhere like South Africa or wherever?
Yeah, I think when I get back, I would love to turn my attention down toward the southern hemisphere. We've noticed some subtle differences that I don't want to get into here because they involve a little more physics. But we've noticed some differences between northern hemisphere and southern hemisphere blocking, and I'd love to get a better handle on that.
So where do you think since most of the southern hemisphere is ocean, roughly, is that going to be more interesting that because the northern hemisphere is quite a bit of land and southern hemisphere is quite a bit of ocean, is that where the differences lie or really not?
Oh yeah, the northern hemisphere gets more of these events, and then the northern hemisphere they occur all over the place: Pacific, Atlantic, Asia. Down in the southern hemisphere, you've got a whole different animal. Like you said, the surface is more ocean, and you get very few, if any, blocks in the Atlantic and Indian Ocean regions. The only game in town is the Pacific area, and for that reason, they get a lot less of them.
And unfortunately, in that area, there's no people and no
Yep.
islands anywhere.
No people, no land, and just blocking.
And would that, and I know we're ending up going back to that, would it end up being for the fact that in the northern hemisphere, closer to the pole, the North Pole would be ocean, more or less, I think, yeah. But the South Pole is on land. Is that where the differences lie? Because you have Antarctica, which is land, even though it's covered by ice, whereas the North Pole is technically in an ocean.
Yeah, the land-ocean distributions, I think, are a big key to this. Because in the northern hemisphere, of course, the land-ocean configuration gives you a nice wave pattern, 2, 4, even 5 sometimes. In the southern hemisphere, land-ocean pattern gives you a far more zonal jet stream, as well as a wave number 1 or 2 tops, and occasionally a 3, but it's just the conditions just aren't the same.
So that would be why, let's say like Australia, the weather is kind of boring. Nothing happens there.
Oh yeah, well, we consider it boring. I'm not sure they would, but to us it's more or less boring, barring the occasional Nathan or lamb that hits them.
So you'll want to go to Australia now, or New Zealand.
I would love to go to some of those areas. One of the places that really fascinates me to go visit is Antarctica.
Which would be kind of hard. I don't think you'd want to live there unless you weren't the tip of it.
Oh, certainly not live there, but visit maybe.
So when we, because I'll get it out, but so when I was speaking of the southern hemisphere, because I always see like all these wave things, and it seems like the jet stream, and you mentioned this, where it's zonal, it seems like it's just quick. The storms just zippity-doo-dah across the southern hemisphere. It could circle the globe in like 4 or 5 days, or maybe 6 or 7. I might be way too fast. Where in the northern hemisphere they get blocked up and they spin around and then they get stopped and then they dissipate. And where in the southern hemisphere it's like boomity boomity boomity, they're just going.
Oh yeah, you're noticing the key differences between the two hemispheres, and it's watching a time lapse of the southern hemisphere from Antarctica's point of view. It's kind of fun watching those little cyclones zip around.
And so when you have something like Cyclone Pam that's in there, and it's moving from the track that I saw, it was going to move straight south and then southeast, which would be right. So I think I'm so messed up because southern hemisphere everything goes the other direction and it's so messed up and it drives me nuts.
Oh, that's right. That's right. And I think Pam is just going to follow the similar life cycle to northern hemisphere events. It'll eventually get caught up in that jet stream and move southeast.
So then, where do you see? And we kind of talked on this, but where do you see the weather enterprise research and whatnot in say 5-10 years? Is more research going to get done? Is there going to be more funding for this, no matter where it's coming from, to get better at where we need to be, even if it's not going to be perfection?
Yeah, funding's always difficult because at least with weather we've got the rules to play by, physics and mathematics. But predicting politics and economics, oh, so I think that funding will probably be static in the next 5 years. It's been so for the last few. And that'll, I think a lot of that is going to be on the climate end. And I think in the last 10 years, it's been very interesting because you've seen this emphasis on climate. You've seen the emphasis on the mesoscale and microscale, the things that affect people directly, and a lot less in the middle.
Yeah, and when you talked about it, because we talked about this when we did our test the other day, that there's the politics are getting involved too much in climate change. No matter if they think it's happening, they don't think it's happening. When we had the governor of Florida say that he's banned his officials from using the term climate change or global warming, and I don't like that. I don't care if they think it's happening or they think it's not. When they can't even discuss it, then that kind of gets to the point, where are we going with this if we can't even discuss if it is or is not?
Yeah, you're seeing a lot of these things cut both ways. Governor of Florida saying don't discuss climate change. People in the House and Senate sending out letters investigating this one and that one for what they think is faulty research or poorly funded research, and so it's cutting both ways. And I think part of it is that some of these politicians feel an emergency situation. They feel a need to have the answer now, in 2 years when they get reelected, or 4 years, or 6 years. And some of the answers are going to take 10, 15, 20 years to get.
And even then, in some cases with research, when you get to a point that you think you're somewhere, you get more questions than answers, and then it could take longer. We may never get there. At least maybe not in my life, your lifetime, or mine, but it might be the next generation that gets it.
Yeah, I think our understanding of the climate system has a little ways to go, and I don't think we'll have the answers in my lifetime.
So yeah, I mean, it's the only thing I want to see is I want warmer winters, but I don't want hot summers. Last summer we had no summer. we did not have, which was a godsend for my electric bill. Because
You and I are on the same wavelength. I tend to favor milder weather or cooler weather. Those hot summers, they get to me.
like more like a Mediterranean type climate where it's kind of warm in the winter and somewhat rainy, but then the Mediterranean climate, especially I'm thinking more of like San Francisco or most of northern and central California, the coast mainly, where it's wet except lightly, and then in the summer, unless it just you get another block, the temperatures tend to be in the 70s and low 80s on the coast, but you immediately go away from the coast and it's 100. So
Oh, oh yeah, those Mediterranean climates would be, I think, a little more desirable.
so besides that, I don't think we have anything else that I can think of because right now you're probably almost completely zonked out getting that it's, gosh, what now, 3 in the morning now there?
Yes, it's now 3 a.m. in the morning here, and I've managed to keep going strong, but if we run out of topics, that's okay.
Yeah, I mean, I have some things because I know this was gonna, I'll get it. I know today was the anniversary of a tornado outbreak that occurred in 1990, and I'm sure you were that was during your time when you were still all about tornadoes. There was the tornado outbreak on March 13th, 1990. Of course, the 25th anniversary is today. And the thing about it was tornadoes this time of the year, they occurred in, gosh, where was it? Texas, Oklahoma, Kansas, Nebraska, Missouri, Iowa, and Illinois.
Oh yes, yes, that was a fairly large outbreak, and I was in Indiana at the time, and we were impressed by the strength of the outbreak.
And in hindsight, when you think about that outbreak, when you think about that month of March 1990, because since I have the website that a bunch of us work on that does weather in Iowa. It was about a couple weeks ago before March started. We went through the storm data from March 1990, and the first thing that caught my eye was interesting to know. March 13th, 1990 tornadoes. I already knew that because one of them, an F4, missed me by 10 miles.
Oh wow.
And I had never seen a picture of that tornado until today when somebody posted pictures of it. And I was
Oh,
like, ooh, this looks interesting. It was a wedge tornado, but then it kind of went through a town as in its rope stage as it was starting to dissipate, and it went through the town in its rope stage and it pretty much destroyed like everything it hit. But I digress.
yeah, and look at how variable things are, because March 13th, 1993 was a superstorm.
Yeah. And the thing that I go back to from March 1990, okay, March 13th, tornadoes. I think it was 5 or 6 days before that, Iowa, especially central and western Iowa, had a horrifically bad ice storm. And I was like, I don't remember that. And then I remembered why. I lived in eastern Iowa, still do. Central and western Iowa had an ice storm. And then I happened to see, not far from me, again, there was another tornado that day. I think it was the 8th of March, 1990. And I was like, I don't remember that. And it was close to Iowa City. It was north of Iowa City and moved northeast. And I'm thinking, I don't remember that, but I do remember March 13th.
Well, that's the beauty of living in our part of the world, in that, especially in the springtime, the weather can be quite volatile and be very cold one week and then severe weather and tornadoes the next.
And that's what back into the climate is really hard for the fact, let's say, for example, this month, March. Here, the first 6 days of the month were horrendously cold. Then snap, I can snap my fingers, then all of a sudden it's hot. All the snow melts, now it's warm, we're a good 20 degrees above average. The beginning of the month, it was a good 15 to 20 degrees below average. So right now, we're probably at average.
Yep,
But
I looked at Columbia's statistics, and they followed that same trend, way below at the beginning and way above now, and it's right now in the middle or average.
that's the problem with going back to the climate thing, where you never know when that thing is going to stop, and when the pattern just snap or flip a switch, and it's going to be different.
Yeah, yeah, the transitions, everything about transitions is very difficult, and that's why I don't do any long-range forecasts for the March-April period or September-October.
Because
Too difficult.
but the transitions, the one that's the worst is winter to spring.
Yep, yep.
Because summer to fall doesn't seem to be as bad, because I think it's mainly for the fact the storm systems tend to be weaker, because the summer systems tend to be weak to begin with, except hurricanes. But I'm talking about mid-latitude systems tend to be weaker. Yeah. But oh boy, I think March in the Midwest especially, March is technically the windiest month. Windy storms, low pressures. You get 90 millibar lows or even lower, and they just start developing. That's how I think from when I looked at this from 1990, we had a fairly strong low pressure center, and you get these volatile weather patterns, and it's climate. You can't do it, and you'd have a difficult time even figuring out 5 or 6 or 7 days in advance. Is this storm going to go do bombogenesis and over land? Is it going to do that? But
yeah, those are the bad seasons to try to predict, and it just shows in the when you look at the climatology of tornadoes. You get your March, April period. You begin to see more of them, and then you get into May, June, and you have a peak. But your stronger ones and your more memorable outbreaks are March and April events, with the exception of the May 2011 outbreak. But a lot of these things are more March and April.
And that's more or less because of transitions.
Yep. The retreat of that cold air and the invasion of the warm.
But then, let's say in the fall, and it seems like, and I said this, when I had Dr. Gallos on from Iowa State last summer, I mentioned this, where it seems like we're starting to get more active weather in the fall, especially in the Midwest, and I specifically went after the tornado outbreak that was in October in Nebraska, namely the Wayne, Nebraska tornado, and into northwest Iowa, because that system was so similar to something you'd see in springtime, but it was in October, and it was in 2012. It was actually the drought year.
Well, I hope that
was it 2013? I don't remember. It was one of those years. It was 2013. That's right, 2013.
Yeah. Well, and I hope my explanation is similar to Bill's. He's a great meteorologist, but I think our understanding of severe weather and when it occurs has changed somewhat in the last 20 years, and we've noticed that October, November can be a secondary maximum in activity, and that's again related to the jet stream's migration through the Midwest as it goes toward the south in the winter. But the difference, I think, between spring and fall events is the spring events have a lot more moisture with them. Yeah. The Gulf of Mexico just provides that extra kick.
And this would tie in somewhat to climatology. Is it another case of perception that we seem to be getting more severe weather events, although some years we get thunderstorms, but does it seem like the perception is worse that there's always been a secondary season in the South in November and even in December, but it seems like it's like moving further north, and it's kind of expanding now into October. And so now you have, let's say, September, October, November, December. It's not going to be as bad as, say, March, April, May, and into early June, but you never know. If the things are just in exactly the right spot, you can get something that's similar to a March, April, May, June event in September, October, November, December.
Yeah, that's exactly right, and I think both things are acting there as perception and the fact that the climatology of these things are changing.
And could we actually kind of get the hint that it could be climate change that's causing this?
Yeah, climate has been changing for as long as the planet's been around. So yeah, climate change is gonna shift these things every now and then, and there'll be some winners and some losers.
Because I went through this because I thought, I look back at tornadoes in Iowa especially, and it seems like, yeah, a lot of our bad ones are in the spring and into the summer. And then I started looking. We've had nasty tornadoes in September. We've had nasty tornadoes in October. We've had nasty tornadoes in November, and we had that weird outbreak in 1967 in January, which was
Yeah.
very odd. And it gets to the point, or is it the perception is there could be severe weather any time of the year, especially Iowa, Missouri especially if you're closer down toward the Arkansas border, but it's the perception there could be severe weather any time of the year if the ingredients are right.
Yes, I think that's a fair statement that any time of year the ingredients are right, you can have those severe weather outbreaks.
So yeah, I just want thunderstorms now. I just want thunder because
Yeah,
like we said in our on the test on Wednesday, I know down in Columbia, you said that it hasn't thundered in like ever. And
yep, hasn't thundered in 4 months there, and I haven't heard it here in Belgrade since the end of August.
is that kind of now you've led me into another thing. Is that kind of normal for them in that part of Russia
Yes,
to get
yeah,
thunderstorms?
yeah. This part of the world, the thunderstorm season's a little shorter.
Okay, I was wondering. Is that mainly due to the geography of where Belgorod is?
Yep, the geography, and it's a little further north. So.
Okay, so I think we've exhausted most of the topics that I wanted to discuss, unless there's more. I can't think any right now without having a headache.
No, it's kind of fun to talk about the weather. I love talking about it, and we were sitting here kind of free streaming it a little, and a little bit of an agenda, but it's always fun to talk about weather.
Okay, I'll ask this. You're in Russia right now. What do you think the tornado season is going to be in the states this year? It's been horribly low this year so far. What do you think? Is it going to stay that way with what has been kind of going on right now?
I almost think that no, that it will get more active even if it's a little later. Again, I think that the cold has been so slow to retreat that it's just delaying the inevitable, so to speak. So I think in April and in May you'll see a little more action. Now, whether it makes headlines or not is always always a question, and we hope it doesn't.
Yeah, because I saw, and I'd bring back the climate models because I saw that it wasn't going to be active for quite some time, and then it looked like late April or especially May onward. Of course, I also saw, this is perception, although I knew this was completely off base. It showed, I think it was like in early May in Iowa, it showed a trough. It had the 540 line right over the state with precipitation. I'm thinking, oh my God, it's like saying there could be like rain and maybe a bit of snow mixed in May. No, thank you. And I immediately threw that out because that is not right. That makes no sense. Because yes, it's not about the precipitation, but the trough made it sound like it was going to be horrifically cold. I'm thinking if it's going to be that cold in May, we're going to lose everything. Because people are thinking, ooh, it's 60 degrees, let's go and plant. The last frost is still 6 to 7 weeks away. But and now the internet has died. I think
Jeff?
I Yeah, are you still there? I think
Yeah, my computer or the laptop stopped because I hadn't touched the screen in so long it just went dark.
oh, it figures. You
Yeah,
probably
and then,
didn't hear anything I said.
well, yeah, I missed after the snow in May, and that brings up a couple years ago,
Yeah.
the Missouri and Iowa got over 10 inches in May.
Yeah, and that's another anomaly because I was mentioning the climate models about a month ago or so. I went back through the climate models for spring, and it showed, like you'd said, that it was going to be active later, but it showed like a trough coming through, and with precipitation with the 540 line. I'm thinking there's going to be, it says rain or maybe a rain snow mix. I'm thinking, please no. And I threw that out because it seemed just completely wonky. Now, of course, as we know, don't time out precipitation because it ain't going to happen. But having that trough there and seeing the height levels being as low as they are for May, I thought that is so anomalous. And it still was in the same pattern as we've been in the Iowa, Midwest, the East, has been in for all of February. I'm thinking, you mean to tell me this is going to last till May?
Well, probably not, but boy, if that one verifies, somebody did something right with that model.
I'd have to look at what it's done lately, because I'm going to probably do that after we're done here. So anyway, we'll do our shout outs. This is what we, if you want to shout out anybody, any website or a book or whatever you'd want to shout out, a person. So
Well,
go.
I'd like to shout out my colleagues at the University of Missouri if they're listening, or if anyone, if any of the students are listening. Hello from Belgrade, and hopefully I'll be back soon. And anybody else at the University of Iowa State, Bill, and anyone listening, hello.
Yeah, are thinking about that since you're leading me down a bad path.
Uh-oh.
With Missouri and Iowa State, they used to be rivals until Missouri decided that they wanted to be rivals with Alabama.
Yes.
So, is there like a rivalry between the meteorology departments at Missouri and at Iowa State?
Um, there's very rarely meteorology rivals. I think a lot of folks in the meteorology world might look at our natural rival of Kansas and, you know, look at that within the context of our general Mizzou-Kansas rivalry. Or, of course, everybody wants to be OU. But you know, the folks up at Iowa State, we know they do a great job, and they know we do as well. And we've sent students their way occasionally, and I'm sure they have the same.
Okay, the first thing I'm gonna say, and this is gonna, I'm gonna get so in trouble. Well, maybe not. Okay, when I was at community college, after I'd been at Iowa State and then realized I am in deep trouble, so then I went to community college. Of course, I didn't graduate calculus. Eh, who knew? Anyway, I took a meteorology course, distance learning, introductory meteorology. Where did I take that? The University of Missouri.
You took our course. All right.
I failed it.
Ah, yes,
I
yes.
do not do well with distance learning, but
Well, there are some things about that course that we're changing, and we have changed it to be more in line with with culture today, using the language of today.
yeah,
I
I
don't think people were smarter 20 years ago, but the way people ask questions and the language used can
yeah,
kind of lead you astray.
but I like I did everything, even though I spent lots of money on that course, and I think it's way more now. I think it's over $1,000 for the 3 credit hours.
Wow.
I kept the meteorology book. I still have it. It's the Meteorology Today book, which is now several editions old, because that's been well over
Oh
10 years.
yes, errands.
Yeah, and I think the newest edition was edition 15 or something that was this year. I think I have like edition 6 or something or
Oh,
other.
oh
6.
wow, you're going back a ways there. Yeah, the latest edition I believe is 11 that we're using.
Yeah, let me. I'm leaving my computer. Let me see. This is yeah. The Meteorology Today book that I have that I got from Missouri is the 5th edition.
Ah, wow, that's going back a few years. Yeah, we've revamped that course now twice since I arrived in 1997, and last year we just decided to completely redo it.
Yeah, the thing is, I'd wonder because I know that you used to or have taught that course before.
Yeah, I'm still the instructor of record for the online course where you get 9 months to complete it. There's also an online course in the summer where the instructor is a little more interactive, and I've taught that once.
Okay, so were you the online instructor in say 0203?
I would have been the online instructor at that time, yes.
Oh,
And
so now I found the person that failed me.
uh, well, what I noticed about online classes is that when I first started with that, very few people ever emailed me. And as time has evolved, more and more folks email me with questions and things like that, which of course I'll answer.
Yeah, because I mean, I kept this book for a reason because I'm like, if I'm not, I need to know something because I have a bunch of other weather books, but so I would assume I'd have to. I doubt the University of Missouri would even have the record of me having done my online course there. But if it is true that you're the one who did it, then I found the person who failed me.
Oh no, no. Well, you're right. This is where we're getting a little bit of trouble. But yeah, at that time, I could probably find the records, and actually, I could probably find them very easily. But again, at that time, I didn't tend to look at the roster of people and see who's in it, and again, folks at that time just took
Yeah.
the course and never emailed.
Yeah, and I think that the problem was with me because I took the tests at the community college, and then they were sent out, and it was so messed up. I mean, I could understand it, but the way I learn by watching. I don't learn very well with reading a book, and I think that's the climate. Talk about climate. The climate has changed. Book. Nobody reads books hardly at all anymore. They read Kindles or them on online, and so it's
Yeah, and that's always the key to success in college or things is knowing how you learn. And sometimes online classes are directed toward ways that one learns that aren't your way of learning, and that can be trouble. Again, the online classes are more straight-jacketed. So,
so yeah. I think we better stop now before we get further into trouble.
Well, I'm sure if you ever took that course again, not that I encourage you to do so, but
Yeah,
if you
no,
ever took it again,
unless you're paying for it.
I was going to say that's the problem. It sounds like you know enough about weather to
Yeah,
certainly have passed that course.
the thing was that was in '02, '03, roughly. I think it was '02. And I'm thinking, yeah, I knew stuff, but it's almost like, what is a cold front? What is a warm front? I'm like, come on, can we get to something more exciting? I was like wanting to go further along, and it's like, no, you got to start at this, and it's like, oh, it's like I know what a cold front is, and evidently I found out I didn't know what a cold front was.
Well, well, again, that's back in the past, and I'm sure you do fine on it now.
Yeah, I mean, but I'll shout out the online course that I failed. I'll shout out the Meteorology Today book too, by the way, that they're on edition whatever number they're on, 45, 7,000, I don't know what number. They're on something. But I'll shout that out. So, speaking of upcoming guests that I have, which I don't have up right now, so I can't tell anybody what we have guests coming. We have several guests. I know Tim Marshall is now scheduled, Storm Chaser Tim Marshall, who's also an engineer, is going to be on April 3rd, pending severe weather. And we're hoping that there is no severe weather, then he'll be on. So we hope that this pattern stays the same so he's on. If not, we're going to blame
Excellent.
Tony. So,
Uh-oh. Well, there's certainly colleagues at the University of Missouri that you can call on, and I'm sure that I could encourage them to come on. So.
yeah, yeah, we well, I'm not going to say that on air. But anyway, so yes, so thanks everybody for watching. This has been the 50th issuance of Polygon, also known as our 1-year anniversary of our third show, because the first two, the year before that, we don't count a whole lot because they weren't good. So anyway, so thanks for joining us. We'll see you next week. Have a good weekend wherever you are, be it in Russia, in Missouri, in Iowa, or in the middle of Cyclone Pam. Have a great weekend. God bless.